Hi, this is Vijayaraghavan. I had created a rock paper scissors game using AI with my team. I have been working as a research intern in Indian servers for the past 3 months and completed this project. The libraries and packages we used are Python, Keras, TensorFlow, OpenCV, and scikit-learn. I created my own data set and trained it for the model. I collected 200 images at different angles and positions for each categories, namely rock, paper, scissors, and none. For this process, I used OpenCV and collected 200 images for each and saved it in an image data directory. I will show it now. Now let's gather images for the dataset. Now we're gonna run it. We are going to collect 200 images for the rock. So here it is. By clicking A, we can start collecting. These are some of the different positions of rocks. Now it has been stored. Repeat the same process for the scissors, paper, and none. Here is our data set. Message. These are the data set. For each categories, we have collected 200 images. Now we are going to train the data set. Initially, we are declaring all the packages and libraries we are needed. Then, declaring the image data directory to the image path variable. Then we are creating a class map dictionary in which the categories are assigned to the numbers. These are the four categories that our classifiers gonna classify. Then the get model function. Since we are using Keras, we are gonna use sequential model. Initially, we will pass the entire squeeze net, which is a pre-trained convolutional network, and now we are going to retrain its output layers to accommodate the three new categories, which are rock, paper, and scissor. This 227 and 227 are the height and width, and this 3 is the color code of RBG. Dropout is used to avoid overfitting. Then the convolution 2D network. Here we are appending this to the end layers of the squeeze net. And we are using ReLU activation function, rectifier linear unit. And finally, we are using global average pooling 2D network. This calculates the average feature map of the average of the feature map in the previous layers. Softmax Softmax activation function is used to get the probability of each gesture. Thus, the model is ready. We traverse through the image data directory and read all the image in each directory. Then the OpenCV converts from BGR to RBG and resets it to 227 and 227 value and then append to the dataset. Then by using zip function, the dataset is passed and data and labels are segregated. Whereas the labels are the one which is not understood by the system, since we use words like rock, paper, scissor, etc. So that by performing one hard end code, the labels are converted to machine understandable language using NP utils from Keras, which has two categorical function. Then we are going to train the dataset, which we use Adam optimizer, and the learning rate I used is 0.001, and the loss is categorical cross entropy since it's a classification. The metric which we calculate for epoch is accuracy, and the model is being fitted with the epochs of 10, which has been an iteration for 10 times, and the model is saved under this name .h5 format. Now we are going to train the dataset. It may take few minutes. Our training have been completed. All the 10 epochs have undergone and the model has been readied. We get a high accuracy and loss is also much lesser. Our model is pretty good. Now we are going for the testing. For testing, we have few images of each categories. Here it is. These are some of the test images we are going to test it. Initially, I'm gonna test it with the paper. Our model have been correctly predicted it as a paper. You can see it here. Now let's check with the other things. I'm gonna check it with rock. Rock. When I pass the rock image as a test, it has also predicted it correctly as a rock. Now let's check with the scissors. Here you can see scissors to have been also predicted correctly, so that we can assure that our model have been working correctly. I had created a simple application with this model. Let's see it. In this application, using Python random function, it will randomly choose a gesture each time and compares with the gesture and produces the winner results. Here is the logic of the rock paper scissors game, and we are loading a model to the model variable, and video capture have been started, and these are some of the manipulations. Now let's run and see it. When I make a move here, my move is scissors and computer move is scissors, so it's a tie. I make another move, it's also a tie. I am a winner. Here the computer is a winner. These are some of the outputs. These are the tested predictions. Here rock has been predicted correctly. Here the paper. Here the scissor. Here none. These are some of the outputs. Yeah, thank you.